Hello, my name is Manish, and today I'm going to talk about how we use basic calculation for the space exploration. Actually, space area it's very deep and vast, but we just going to talk about very basic calculation used in space exploration. I have very keen interest in the space area, so I follow a lot of space news. Recently, India did its third moon mission to the southern part of the moon, that is the darkest place that moon have. Even sunlight cannot reach there. So these are the photos I got from ISRO, Indian Space Research Organization. uh, the second photo you can see on the right bottom, yeah, it's taken from the Vikram lander itself. And that rover on the photo, you can see it's Pragyan rover on the surface of the moon, that is the southern part. So we gonna come back to the topic. So calculus we use in space exploration. As per the Einstein theory of relativity, space is curved. So actually the gravity itself is byproduct of curved space. And for curved space, we usually use differential calculus to help us to understand the curved space and graphs. So calculus can be used to determine how much fuel we need for our engine to minimize fuel consumption and maximize spacecraft performance. So our basic concepts such as derivative and integral, they can help us to optimize our fuel efficiency, because you have to know how much right amount of fuel you need for the rocket. If you put less fuel, you're gonna see your rocket earlier than expected on the ground. But if you put then you would say put more fuel. But in the space exploration, it cost you billions of dollars to put one satellite into the space. Escape velocity. So calculus can be used to calculate how much velocity rocket should need to escape the gravitational pull of the Earth. Actually, it's very complicated procedure, but for the sake of this presentation, we just gonna do in a simpler way. And it's very complicated because as rocket move further and further, it's going to burn off a lot of fuel, and its mass will be getting lighter and lighter. So here we have ideal rocket equation that can be described as instantaneous mass of a rocket into change in velocity of a rocket plus change in instantaneous mass of a rocket into velocity of exhaust. It should be equal to zero because conservation of momentum, and momentum is mass into velocity. And if we take that second half into right side, we get negative. And if by doing integral we get delta of change in velocity of a rocket, and that can be described as negative velocity of exhaust into log instantaneous mass of a rocket mass full divided by mass empty, that we use reciprocal rule and set limit to empty to mass full, and then we get this formula. So just for example, here we got this formula, and I just put random numbers into it, and we got velocity of a rocket, it should be. And I can send my rocket to the moon now. So calculus can be used to calculate the trajectories or our star or planet or even our rocket trajectory. Here on the left side we can see the time, relative velocity and range of a real-time rocket launch. So for the calculation of a star and planets trajectories, we use some calculus, mostly integration, because by using particular time data where it gonna be revolving and moving, we add up all the data, and we can predict exact location of that planet in the end. So I would say calculus has many application in real life, either on Earth or even in space. As we know, maths is ultimate language of the universe, so that can help us as a human race to explore more further. So I hope you like this presentation. If you have some question, you can write down in the thread. And thank you so much.